Between the 10th and 12th centuries, the way buildings handled weight changed. Structures shifted from heavy, defensive stone piles to skeletal frames filled with glass. To understand this transition, we have to look at the physics behind the masonry. In the early Middle Ages, the primary objective of architecture was unshakable solidity. Buildings like Spire Cathedral relied on sheer mass to stand the test of time. The defining feature of these structures is the rounded or Romanesque arch. When gravity pulls down on a rounded arch, the shape forces that weight outward. Engineers call this lateral thrust, and it puts immense pressure on the sides of the arch. To keep that outward pressure from blowing the arch apart, medieval builders were forced to flank it with incredibly thick, heavy masonry walls. Because these walls were actively working to contain the building's weight, cutting a large hole into them would remove that essential support. The structure would crack and collapse. As a result, builders could only safely include tiny, narrow openings. This lack of natural light directly caused the dark, gloomy interior mood that defined the Romanesque era. Romanesque engineering was bound by an inescapable trade-off. In order to build high and remain stable, you had to sacrifice light. By the 12th century, religious leaders like Abbot Suger began arguing that earthly light contains divine light. They wanted vast, luminous interiors, but builders faced strict physical limitations, still hoisting stone by hand with rudimentary wooden pulleys. Adding large windows created a structural crisis. Replacing a section of a load-bearing stone wall with glass removes the support holding up the heavy roof, causing the ceiling above to cave in. The first major technological solution to this problem was the pointed arch. Instead of pushing the weight outward, its steep angle directs the force sharply downward. Because the weight travels cleanly down a vertical path, the sideways pressure on the walls drops dramatically. Changing the geometry of the arch altered the path of the building's weight, allowing the exterior walls to become thinner. But thinner walls still could not support a massive continuous stone ceiling. Builders needed a way to lighten the roof itself. They solved this with the ribbed vault. Instead of a solid block of masonry, the ceiling's weight rests on a concentrated skeleton of intersecting stone ribs. Even with a lighter roof and pointed arches, reaching towering heights required one final leap: the flying buttress. This structure acts as an external skeleton. It catches the roof's weight, carries it away from the walls, and grounds it into heavy exterior pillars. By pushing the entire structural load outside, the walls became entirely non-load bearing. Builders could now replace the stone almost entirely with massive stained glass windows. Let's test this visual vocabulary on a real-world hybrid building. The Basilica of Saint Denis took centuries to complete. Can you spot the transition from Romanesque to Gothic engineering? At the very base of the structure, you find the heavy, rounded Romanesque arches. Move to the upper sections, and you see the Gothic pointed arches and a large circular rose window. These combined technologies culminated in the late Gothic era. Structures like Chartres Cathedral featured towering spires, delicate stone tracery, and massive rose windows. Here is the final breakdown. Romanesque engineering relies on round arches, thick walls, and tiny windows. Gothic engineering relies entirely on pointed arches, ribbed vaults, and flying buttresses to support vast panels of stained glass. Over 3 centuries, builders mastered the forces of gravity and lateral thrust. They turned the heavy, earth-bound fortress of the soul into a delicate, soaring temple of light. If you want to explore the engineering of medieval architecture further, pause here to review our sources.